In this video, I'm going to do the first 4 problems of the 2.5 homework. So our topic is optimization. So question number 1 says, for what x does the function g of x equals 10 plus 40x minus x squared have its maximum value? So what you want to do is you want to first note that question 1 has a parabola as the function in question. So that's the first thing to note. Then what we're going to do is we're going to write out that equation, and then we're going to go ahead and take the first derivative and see where we are with that, because that's going to enable us to maximize or optimize the function. I noticed, looking at my parabola before I've done any work whatsoever, I noticed that it is a downward facing parabola. So I know that it's going to look something like this. So let's see if we can write that first. So we have g of x. Oops, I don't want to do a prime yet. Okay, so just plain old g of x equals 10 plus 40x minus x squared. Now when you're doing your homework, what you should do is just think about what we have here. This is x, whoops, let me try that one more time. X squared, okay. We know that the shape of this function, okay, 10 is your y-intercept, so that's there. It looks like this. So I know if I find where the slope is 0, that's going to give me the x, that's the critical value that will maximize my function. So g prime of x equals 40 minus 2x. I'm going to take the second derivative right away, and that's going to equal minus 2. Since the second derivative is minus 2, I have affirmed that I have a concave down function, which is what I saw here when I graphed it. Okay, so now I know whatever x I get when I set my first derivative equal to 0, and that x, by the way, will be 20, will maximize my function. So I would write that up, that I know I have a maximization because of the second derivative test. And let's go back and figure out what the question is. They only want to know the x. And when I set this equal to 0, I get 40 equals 2x, and therefore x equals 20. So my critical value, so xCV, equals 20, and that answers my question. So that's the end of question 2. I have done a second derivative test, and I would write down a comment about that as well. Okay, so the second derivative is negative, therefore function is concave down at critical value, which leads to a max. Alright, so that problem is done. I did not have to figure out an objective function. I didn't have to figure out a constraint. Those things are still coming. Let's move on to question number 2. Okay, question number 2 says, find the maximum value of the function f of x. So let me start writing this down. F of x equals 12x minus x squared, again, a downward facing parabola, and give the value of x where the maximum occurs. So I need to find out, first off, what fx max is, and then I also need to know what the CV, the xCV is. So this is my goal. So I have to give 2 different answers. So first off, I'm going to sketch this. This is going to start at the origin and come up and down. And I don't know where it maxes out, but I'm going to discover that by finding where it has a slope of 0. And I do that by setting this derivative equal to 0. So let's take the derivative, and I get 12 minus 2x. Let's go ahead and take the second derivative, which is negative 2, which tells me that the original function is always concave down. So if it's always concave down, that means that when I find the critical value, it's definitely going to be a max. So let's go ahead and find that critical value by setting the first derivative equal to 0. So 12 minus 2x equals 0, where x is 6. So now I know that the x in question is 6. So let's make a statement about my second derivative test. So I'm going to say that f prime prime of 6, we'll say, is less than 0. That makes it concave down, and therefore we have a max at xCV of 6. Okay, that's our statement. So here's one of our answers. The other answer we have to get by plugging in 6 in the original function, and that's going to be 12 times 6 minus 6 squared. So what's 12 times 6? 6 times 2 is 12, so that's 72 minus 36. That equals 36. So our function value will be 36, and our critical value for the x will be 6. And you have completely answered that question. Let's move on to question 3. Okay, question 3 is a little bit different. It says find the minimum value of f of t equals t cubed minus 6t squared plus 40. And they want t to be greater than or equal to 0. So it says to find the minimum value. All right, is my procedure any different? This is a cubic function, so there's a good chance I'm going to have a minimum and a maximum. So let's go ahead, and I see that if I have a minimum and a maximum, both locations can be ascertained by taking my first derivative and setting it equal to 0 and see where these features occur. So let's go ahead and do that. So f prime of t equals 3t squared minus 12t. Okay, so I'm going to go ahead and take the second derivative as well. And that's going to be 6t minus 12. Okay, so I'm going to set my function equal to 0. And what happens when I do that? I'm going to need to factor. So let's do that down here. So what do they have in common? It looks like a 3t. I pull that out, and I say this is going to be t minus 4. So I get two factors. One factor I get from setting this first factor equal to 0, and when I do that, I get t equals 0. So that's my first factor. If t is 0, what is f prime prime of that t? So f prime prime of 0. That looks like that's going to be negative 12. Okay, let's keep going. Now look over here. I have t equals to 4 is my other factor, and remember these factors are where my function has a slope of 0. So if t equals 4, let's figure out f prime prime of 4, and plugging it in, 4 times t, so I'm plugging it in right here, is 24 minus 12 is positive 12. All right, so the first critical value I tested gave me a negative second derivative. If I have a negative second derivative, that means that the function at that point is concave down, which gives me a max. If I have a positive second derivative, which I do at 4, then that means that my function is concave up at that point, and that gives me a min. So go back to the question, find the minimum value of f of t, and give the value of t where this minimum occurs. So it looks like t of 0 and t of 4 are both acceptable answers because they fall within my domain as indicated by t being greater than or equal to 0. The one that gives me a minimum value is 4 based on my second derivative test. So far my answer is going to be t equals 4. Then what you're going to do is you're going to figure out what the f of 4 is. And when you plug in 4 into the original equation, you get 144. So I'll leave that for you to do. But those would be the two answers that you need to satisfactorily answer question number 3. Now we're going to go on to question number 4. Okay, question number 4 says, for what t does the function, and let me start writing this down. So the function f of t equals t squared minus 24t have its minimum view. Okay, so I know from looking at this function that this function is going to be upward facing. Okay, so the function is back up will be this shape because the leading coefficient in front of the t squared is positive. So then I know that the critical value I get will give me a minimum just by thinking about the function. Okay, so now let's take the first derivative so I can find where that slope equals 0. And I get 2t minus 24. So I'm going to go ahead and take the second derivative. That's just going to be 2. The second derivative is positive. I have verified that the function is always concave up because there's no variable in my second derivative. Set my first derivative equal to 0, and I find that that's true where t equals 12. So we are done because all they ask is for what t value does the function have its minimum value. So you would write about your second derivative test, which is right here. You would say that since f prime prime of your critical value, which is 12, is greater than 0, therefore the function is concave up where t equals 12, which leads to a minimum f of t. Okay, so we're done with that. So these first 4 did not have any complications in that you had to get your objective function yourself, you had to get your constraint, and you had to modify. We're going to do that in the next problems, in the next video as well.